Assalamualaikum. My name is Muhammad HASBULLAH, and today we are going to present about our experiment, which is heat radiation. So our group consists of 6 people, which is Muhammad RAIS, myself, Muhammad HASBULLAH, Muhammad Syuaib, KOGULAN, AMIRUL, HAZIQ, and one Muhammad ALIFF. So for the introduction for this experiment, so heat transfer can transmit through 3 ways, which is conduction, convection, and radiation. So for the conduction is the direct flow of heat through a material resulting from the physical contact. So for the convection is the heat transfer between a surface and adjacent fluid, and by the flow of fluid from one place to another induced by the temperature. And lastly is the radiation. So radiation has no transfer medium required, and it is transfer of thermal energy through matter of space by electromagnetic wave. So actually, for the experiment is radiation. Radiation is which is the electromagnetic wave energy discharged from a source and communicated through all the space at the speed of light. Radiation is normally happening surrounding us and can be found all over the place. A portion of a normal radiation model can be found in the nature, which is warm radiation, which is heat from the sun. Radiation which can be found in the dirt and rock, also known as early stage of the earthly radiation. Moreover, the radiation that come from the space are called enormous or cosmogenic radiation. A portion of the instance of radiation around us is in everyday life a smoke alarm to guarantee security of individual by notice them fire hazard. Then that is extreme machine to help the specialist distinguish and catch picture of occurrence occur in understanding body in clinic and use for location of weapons in the air terminal. In this trial, we will be centered around what we discuss mean for the radiation with the guide of radiometer gadget.
Warahmatullahi wabarakatuh to Madam. My name is Wan Muhammad Alif bin Wan AZLI, matrix number NA18115. I will continue with literature review. The Stephen-Boltzmann law, also known as Stephen law, states that the total energy radiated per unit surface area of a black body in unit time is directly proportional to the fourth power of the black body's thermodynamic temperature. Mathematically, Stephen-Boltzmann law can be written as below. The heat transfer from one radiating black surface to another is dependent on the amount that each surface can see of the other surface. In order to solve radiant heat transfer problem, an area factor is introduced where F is defined by the fraction of energy emitted per unit time by one surface that is intercepted by the other surface. Thus, the time rate of radiation heat transfer between two black surfaces of A1 and A2 at temperature T1 and T2 respectively is given by below. Therefore, area factor are found by analysis, numerical approximation, and analogy, and result for common configuration have been published in geographical form. That's all from me. Thank you.
Assalamualaikum and hi, my name is AMIRUL HAZIQ bin ZAINUDIN, and I will continue the presentation to present the experimental procedure of test 1, which is to show that the intensity of radiation varies as the far power the source temperature as stated in Stephen-Boltzmann's law. First, one of the thermocouple of the target plates T1 was connected to the service unit and placed the plate on the bench to record ambient temperature. Next, the radiometer was positioned on the test strip at 800 mm from the heat source. And number 3, the selected knob on heat transfer service unit was selected to read the radiometer measurement. Next, number 4, the heater temperature was set to 250 degrees Celsius by heater controller. Monitor T4 reading on the heat transfer service unit. And number 5, when the T4 value has stabilized, the radiometer was moved to 300 mm from the heated plate. The reading of the radiometer should start to rise. When the value has stabilized, T1 T4, the distance x, and the radiometer reading R was recorded. Number 6, the radiometer was moved to 800 mm from the heated plate again. Next, the above procedure was repeated with an increment of 50 degrees Celsius from 250 degrees Celsius to 400 degrees Celsius. And number 8, the relationship between the Stephen Boltzmann's law and corrected radiation reading, which is RC, given as a factor of F, is calculated. And next is test 2, which is to demonstrate that the exchange of radiant energy from one surface to another is dependent upon their interconnecting geometry. First, the aperture holder was installed at 200 mm from the heated surface. Then the radiometer was installed on the track at 800 mm from the heated surface. Next, supply 400 degrees Celsius to the heaters. Monitor T4 indicator reading on the heat transfer service unit. And next, number 3, when T4 value has stabilized, the radiometer position was moved to 100 mm from the aperture position. The reading of the radiometer should start to rise. When the value has stabilized, T4, aperture width, and R was recorded. And number 4, the aperture plates were installed on the aperture holder and adjust the width to 5 mm. And again, T4, aperture width, and R was recorded when the reading has stabilized. And next, number 5, the gap was increased with an increment of 5 mm increment, and the above procedures was repeated. And then number 6, calculate the area factor. And number 7, area factor against aperture width, which is in millimeter, graph was plotted. Thank you.
Greetings to Doctor. I'm KOGULAN unlike MANIAM. My entry ID is MA18098, and I would like to present about the result and calculation part. So first result here is for the test 1 result, where to show that the intensity of the radiation varies as the fourth power the source temperature as stated in Stefan Boltzmann law. So here is the heater temperature, which is the corresponding variable, and manipulated variable, and the distance is the constant variable, and the radiometer reading is the responded variable, and T1 T4 reading here shown. And for the test 2, to demonstrate that the exchange of radiant energy from one surface to another is dependent upon their interconnecting geometry. So the first table here shows the width, where from the scale from 5 to 40 mm, where the scale is increased about 5 mm for each reading. And then the X, the area factor is static by is 100 mm, and the R value is equal here is given. The next part is the calculation for the relationship between Stefan Boltzmann law and the corrected radiation reading RC, where here you can see the QB, the formula for Stefan Boltzmann is 5.67 times 10 to the power of -8, and then the 523.5 is where the value taken from the temperature here T1, where 250 plus 273 when changed to Kelvin, and then minus 291.15 the power of 4. Then you get your QB value. R value is given where we took it from the table. And then for the tan tangent, where arc tangent equals to 50 over 100, and you get your tangent. And QR, the formula where R sine square theta, and then the correction factor is equals to C equals to QR over R. Then you get your C correction factor value 1.13, and then this is the graph from the data given above. This is the graph generated from where the area with aperture opening. So now I would like to let my colleague to speak about this graph more detail. Thank you.
Assalamualaikum warahmatullahi wabarakatuh to Doctor. Today I will present about discussion for question 1 and question 2. So for question 1, what actually happens during the heat radiation process? So as we know, the temperature changes in molecules, atoms, and electrons produce the heat radiation, which is limited by the substance. So as the temperature rises, so does the rate at which heat radiates. The volumetric emission, absorption, or transmission is a result of the radiation which being continuously emitted and absorbed or even transmitted throughout the volume of matter in all solid, liquid and gases above absolute zero temperature due to the motion of electrons, atoms and molecules. It is a surface phenomenon when it comes to opaque items because the radiation emitted by the interior region cannot reach the surface, and radiation that strikes the surface usually absorbs within a few microns of the surface. So that's all for question 1. And next for question 2, what is the most significant point that can be deduced from the relationship between the Stephen-Boltzmann law and the corrected radiation reading, which is known as RC. So the total blackbody emissive power, which is known as EB, as determined by the Stephen-Boltzmann law, is equal to the sum of the radiation emitted at all wavelengths. So EB can only be calculated using R, which is the energy emitted by a unit area of blackbody surface for a radiometer calibrated to measure the radiation. So due to the mathematical relationship in the Stephen-Boltzmann law, when the corrected radiation reading R increase, the thermodynamic temperature will also increases. So the picture below is the formula for the equation for the blackbody radiation. So that's all the two questions for discussion from me. The next question 3 and 4 will be presented by my colleague. That's all. Thank you.
Assalamualaikum. My name is Muhammad Suhaimi, metric number MA18113. I will continue on the discussion on the number 3. Discuss about the graph that we have plotted. So as you can see, there is a graph, area factor with aperture opening. The area factor increase when the size of the aperture opening is increased. So the area factor is very important because the rate at which heat move from the one radiating black surface to another is based on how much each surface can view of the other surface. Next on the question number 4, what factor will affect the radiation process? First, transmissivity. The fraction of light that is transmitted is a very swift wavelength. The greater the transmissivity, the less incoming radiation that can pass through the substance. Next, absorptivity. Variable depending on the temperature of the incident radiation origin source. So the lower the temperature, the greater the absorptivity. And next, emissivity. The radiation emitted to the surface at the specific surface is compared to the radiation emitted by a black body at the same temperature. It's called an ideal conditions. And last, reflectivity. It is determined by the direction of the incident radiation and the incident of the reflections. And lastly, for the conclusions, all through these exercises we can group that large number of the method of heat transfer, which is convection, conduction and radiation. So radiation varies from the conduction and the convection, in that it doesn't need the presence of a material medium to happen. Then at the point we distinguish the pace of thermal radiation emission increment with expanding temperature. Thank you. That's all from our group.